Hi, welcome to Learning Math with Mike. So today we will cover products of two simple factors, quadratic expressions. As a product of two simple factors, factoring by quadratic expressions, ax squared plus bx plus c when a equals 1, and use of the quadratic equation. Okay, let's start. So first we'll start off with a plus b all in parentheses squared. So to factor that out, we take a plus b times a plus b, and we start the FOIL. First, outer, inner, last. So we have a squared plus ab plus ab plus b squared. And that's the basic formula for products of two simple factors. Next, we're going to do the same thing but with different signs. So we'll have a plus b, parentheses, a minus b. So how this changes is you have to put the subtraction sign into some of the variables. So we have a squared plus ab minus ab minus b squared. These cancel to 0, and we are left with a squared minus b squared. So next, you can use all this stuff in reverse too. Call it reverse algebra. So if we look at this, a squared plus 2ab plus b squared we can turn it into a plus b and parentheses squared. And we know that because of how we did it up here. So we can already just look at the equation. So you gotta have two a's and two b's. Right? It's just addition. So you can add the addition symbols in that, and then you essentially get a plus b, parentheses, a plus b, and parentheses squared. So, and this is a beginning video. In other videos, I will cover pre-calculus, trigonometry, calculus, differential equations, linear algebra. This will all be included in my subscription, which will come a little later down the line. But enjoy these videos as they come out. Next, we're going to do, say we had this same thing. We have to go backwards, and we have a squared minus b squared. So you know there's two a's and two b's. So a, b, b, and then subtraction, so it's a plus and a minus. And you already know that because a squared plus ab minus ab minus b squared. ab minus ab equals 0, same as here, and then we will get a squared minus b squared. All right, so check, check, check. We covered the 3 concepts with just using FOIL. Now it's going to get a little more interesting. We're going to add new and different variables before we hit the quadratic equation. All right, so let's go with x plus g parentheses x plus g plus times parentheses x plus k. So from here, you can already probably do this in your head. You got x squared plus 2gx plus gk, right? Because gx plus gx equals 2gx. You combine the terms. And we get our expression. And then we can even go one step further and factor this. You have x times 1 or x plus 2g plus gk, which would also equal x plus gk times x plus 2g. Simple factorization right there. Next, we're gonna, now that we've done that, and you know you can do that with the plus and subtraction, so we can go over and start factorization with the quadratic equation. And then to start off, we go ax squared plus bx plus c. When a equals 1. So when a equals 1, x squared plus 5x plus 6. So to factor this, we start, make the parentheses. We have 2 x's, right? And then we have a 5 and a 6. So 6 times 1 is 6. So we have 6, 1, and it's both, we have 2 additions here, so addition, addition. And if we FOIL this, we got x squared plus 6x plus 1x plus 6. This gives us x squared plus 7x plus 6. So we have to go and look now. Does this equal this? Oops, no it doesn't. Because it's true that 6 times 1 equals 6, but when you FOIL it out, after you do that, you're gonna get an equation that's a little off. So what we do, you know it has 2 x's, so you have 2 pluses, and then you have 3 plus 2 is 5. So this becomes our answer. So next we'll do one a little more challenging, where a will not equal 1, right? So we'll do 5x squared plus 6x minus 11. This is just a random one I made up. So basically, this would be difficult for us to factor, because yes, you can pull the 5 out, or can you? No, you can't, because you can't pull 5 out of these, either of these. So we have to use the quadratic equation. So this is a, this is b and this is c, we have ax squared plus bx plus c, and the quadratic equation equivalent to that is minus b plus or minus square root of b squared minus 4ac all over 2a. So now all we have to do is plug the variable. We have to plug the numbers in to where the variables show. So we have minus 6 plus minus square root b squared, 6 squared, which is minus 4. And then we go 5 times minus 11. The minuses cancel. All over 2a. 6 divided by 2 becomes 3. So what we're left is minus 3 plus minus square root 36 plus 11 times 5 is 55, and 50 times 4 would be, I believe it's 220, but we'll see. So 22. Yep, 220. All over a, which is 5. And simplify it. 3 plus minus square root of 256 over 5. And we have our answer. So there's one more I want to show you. And this is what happens when you have imaginary numbers, right? Anytime you have a negative number inside a square root, you pull the minus out and it turns into an imaginary number. Let me show you. And with the quadratic equation, you also come out with 2 x's. In this case, sometimes it's 30. So you're going to have x1 and x2, right? So, to show you what it looks like, x1 would be minus 3 plus square root of 256 over 5. And x2 would be minus 3 minus square root of 256 over 5. And there you have your answer. But when you're dealing with imaginary numbers, we have to take a different route. So we'll go with this one. So 30x to the third plus 5x squared minus 3x plus 11. So right here we see we need to simplify this a little bit before we can run the quadratic equation, because what you can do is pull 5 out. We're only going to do these two. So you can pull the 5x squared out, start the parentheses, x or 6 x plus 6x plus 1 minus 3x plus 11. And next we have 5x squared minus 3x plus 11, all in parentheses, times 6x plus 1. So, because this is a cubed root, we're going to have 3 x's. x1, x2, and x3. So, next we look at this. We're going to have to throw this into the quadratic equation because you can't equate this any other way. So, we have minus negative 3 plus minus minus 3 squared minus 4 times 5 times 11, come here, all over 2 times a, which would be a 5, which turns into 10. And then these negatives become positives, and we are left with 3 plus or minus square root of 9 minus 55, 220, all divided by 10. So next, 9 minus 220 is minus 111. So we have 3 plus or minus square root of minus 211 over 10. So we have the negative here, so turn it to a positive and pull out the imaginary number. And then this becomes our answer for this will be x1, x2. So x3 would be the expression 6x plus 1 if you equal 6x plus 1 equals 0, 6x equals a minus 1 because you pull this to the other side, divided by 6, x equals minus 1 over 6. So, there you go. x1, x2, and you got your x3 right there. I hope you enjoyed this video. We will have more in the next one. Stay tuned.